This is the fourth lecture of the series and second chapter in the book. The name of the chapter is Polynomials. Polynomials. In brief, you have studied it in 9th class. What is the difference between an algebraic expression and a polynomial? Algebraic expression and polynomial. Whether it is an algebraic expression or polynomial, they contain terms. And each term has a numerical value and some power of x. The power of this must be a whole number. Must be a whole number if it is a polynomial. And if it is not whole number, any fraction, negative, whatever point, decimal, then it is algebraic expression. That depends only on this. If it is whole number, then it is polynomial. If it is not whole number, then it is algebraic expression. So algebraic expression may be written as say 4 x to the power 3 by 2 minus 2 x square minus 4. This is algebraic expression because this term is having power 3 by 2 which is not whole number, whereas 4x square 4x cube minus 2x square minus 4 is a polynomial because the powers are whole numbers. Here you may say that there is no x, but this may be written as x power 0. 0 is also a whole number. X power 0 means 1. So in polynomial, the powers of x are whole numbers, and the coefficient of these, which is this coefficient of x cube is 4, coefficient of x square is minus 2, coefficient of x to the power minus 4. Or you may term this as constant term also. Constant term is minus 4. See, okay. Polynomial may be linear, quadratic, and so on. What is a linear polynomial? A linear polynomial, for example, is ex. Ex means polynomial and x in x. Here the variable is x. You may write here a even. Generally, it is written as p because polynomial first word of the polynomial is p. Therefore, they write p. It may be written as ax. This is polynomial a in x. X is the variable. If it is linear, we can write this as minus 4 x plus 3. This is linear because the highest power here is 1. Here the power is 0. Highest power is the degree of the polynomial. Degree is 1. Degree of this polynomial is 1. Degree is 1. And if the degree is 1, then it is linear, called linear. Why linear? Because its graph will be a straight line. Because its graph will be a straight line. Okay. Now examples of linear polynomials. Bx is equal to x, simply x. Cx is equal to 3x. Dx is equal to x by 2. Ex is equal to x by 2 plus 1 upon root 2. See, here the coefficient may be irrational, may also be irrational. It may be rational or irrational, whatever, any number. Say root pi. Pi is irrational, so root pi is also irrational. Root pi x square minus 4x is a polynomial. The coefficient may be anything. Okay, if it is a quadratic, then the coefficient of x square, will not be 0. A quadratic polynomial may be written as ax square plus bx, generally written as bx plus c. A not equal to 0. If a is 0, then it will be linear. If a is 0, then it will be linear. So you must write that a not equal to 0. Another example of this will be ax square plus bx. Third example may be x square plus c. The highest power is 2. If the highest power is 2, then the polynomial is quadratic, or the degree of the polynomial is 2. If the degree of polynomial is 2, then it is quadratic. I told you that it is called linear. The highest power is 1. Here also 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 the highest power is 1. If the highest power is 1, then we say that the degree is 1. And in other terms, we say that the polynomial is linear. Linear means the graph will be a straight line. Graph will be a straight line. If it is quadratic, then the graph will be a parabola. It is, if you plot it this, it will be parabola. Okay. First, let us plot linear one. Here we will plot x, the variable of the polynomial, and this side polynomial. Generally, usually people say that it is y is equal to px. It may be written px only. Px only. So we are plotting px versus x, graph of this bx. What will be bx? If x is equal to 1, we are plotting bx is equal to x. If x is equal to 1, then the value of the polynomial will be 1. Graph, this is scale 1, 2, 3, 4, and so on. Here also 1, 2, 3, 4. If the value of x is 1, then the value of the polynomial is 1. So you get this point, 1 in x and 1 is px. If it is 1, it is 2, then the value of the polynomial will be 2. So you get this point. A little bit of coordinate geometry must have read in 9th class. This. If it is 3, x is equal to 3, then the polynomial value is 3. As the polynomial is x itself only. If you join it, it will pass through this origin 0, 0. If the value of x is minus 1, the value of polynomial will be minus 1 here. Okay, so it is straight line. This angle will be 45 degree. And in terms of pi, it is pi by 4, written as pi by 4. Pi radian is equal to 180 degrees. 180 degrees. So pi by 2 radian, here the unit is radian, whereas here the unit is degree. Pi by 2 radian is equal to 90 degrees. Pi by 4 radian is equal to half of this, that is 45 degrees. So it is 45 degrees, and your polynomial is px is equal to x. Polynomial is x. Now where will be the value, where will be the what will be the graph of px when it is equal to 3x? Yes. When x is equal to 1, if it is 3x, if px is equal to 3x, when x is equal to 1, the value of px is 3. Here. Here. So px is equal to 3x will be this. Graph for this will be this one. Yes. Okay. This is for px is equal to x. This is for px is equal to 3x. What will be the graph for px is equal to x by 2? It will be like this. This way. This is px is equal to x by 2. So remember it. If it is more than x, this way. If it is less than x, then this way. From this 45 line. Okay. So this is how we plot linear polynomials. It is px is equal to 3x. Now what will be the value? What will be the plot for px is equal to x plus 2? Px is equal to x plus 2. Okay. This is one plotting px this way, plotting x this way. 1, 2, 3, 3, 4, and so on. 1, 2, 3, 4, and so on. So it is this at 45 degree, it is x plus x. Px is equal to x. Px is equal to x. If it is 45 degree, it is px is equal to x. What will be px is equal to x plus 3? Px is equal to x plus 3. When x is equal to 1, the value of px is 4, not 1. If px is equal to x, then the value of px is 1 when x is equal to 1. And when px is equal to x plus 3, the point will be this. Okay, point will be this. So straight line passing through this point. You may plot other points also. So okay, so it is px is equal to x plus 3. X plus 3. Now let us plot px is equal to 3x plus 1. 3x plus 1. Px is equal to 3x plus 1. Px is equal to 3x plus 1. Okay, this is 1, this is 2, this is 3, this is 4. Similarly here 1, 2, 3, 4, 4, 4. This way x, this way px. The variable may be t even. The, uh, the, the, the linear function may be 3x plus 3t plus 1. then we write PT because that is polynomial is in T. Polynomial in T is 3t plus 1. So you will be writing here T in place of X. Okay. Even Y, that will be much confusing. 3y plus 1. Then you will write here Y. Okay. So here we are plotting Px is equal to 3x plus 1. What will the say? What will be Px is equal to x, and then what is Px is equal to 3x, and then what is Px is equal to 3x plus 1. First will be x, then 3x, and then 3x plus 1 to let you know what is the difference between Px is equal to x passes through this point, that is at an angle of 45 degrees. This is Px is equal to x. What will be Px is equal to 3x? 3x. When x is equal to 1, Px is equal to 3. So here is the point. Join this. This is Px is equal to 3x. This is Px is equal to 3x. Px is equal to 3x. Now what will be Px is equal to 3x plus 1? At every point you increase the value of Px by 1. 3x, 3x. Take this, and every point you increase the value of Px by 1. So here it is 0 for this. It is 0. Make it 1 here. So any line parallel to this and passing through this will be 3x plus 1. Parallel to this will be 3x plus 1. Yes. Okay. This will be Px is equal to 3x plus 1. If it is minus 1, and any line parallel to 3x, Px is equal to 3x, and parallel to this, passing through this point will be 3x minus 1. Yes, okay. Passing through minus 1 will be Px is equal to 3x minus 1. This is Px is equal to, the middle one is Px is equal to 3x. This is Px is equal to x. This is x. This is 3x. This is 3x plus 1. And this is 3x minus 1. Okay, now you can plot any linear polynomial. Let us plot quadratic polynomial. Let a quadratic polynomial will not be a straight line, it will be parabola. Number 1 point. A quadratic or plot of quadratic polynomial will be a parabola, not straight line. A straight line for linear only. If the power of highest power is 1, if the degree of the polynomial is 1, if the degree of the polynomial is 2, highest power of the polynomial, that is highest power of the x of the variable is 2, then it is quadratic. Examples once again is 4x square. Example, x square minus 3x. Examples, x square minus 3x plus 3x minus 1. Anything. Highest power is 2. Highest power is 2. Highest power. All these polynomials are quadratic. And their plot will be a parabola. What is parabola? First, let us know. What is a parabola? You take a line, fixed line. This you will study in class 11. What is parabola? A fixed line and a fixed point. This is a fixed line and this is fixed point. In class 11, you will know that this is called directrix and this is the focus. Okay, these are fixed. These are fixed. These are fixed. This is directrix and this is the focus. Now how to plot a parabola? Parabola, the shape of the parabola will depend upon the position of this with respect to this. With respect to this. If the directrix is like this, your focus is here, the parabola will be like this. Okay, now take any point. How to plot a parabola? You must know it. Take a point P such that its perpendicular distance from this line, fixed line, and its distance from the focus S are same, equal. This distance equal to this distance. You take a point P so that its perpendicular distance from this fixed line, this is the perpendicular distance, and the direct distance between this point and the focus and the fixed point are same. Both are same. Okay, then it is good. Now the second point. Any point in point and between this and this will be from this point the perpendicular distance will be this much, and from this point the distance of this fixed point will be this much. Both are same because this is the middle point, so this is the second point. Now consider this point. Draw perpendicular from this and join this. If they are same, they are not same, they do not look same. So from this, yes, they are same, equal. This equal to this. If this is equal to this, then take this also. Okay. Here, this side, this distance, this distance is equal to this distance. Okay. Then this point. There will be infinite points you may find. And join these points by a curve. By a curve, not a straight line. By a curve. Whatever figure you obtain is that of parabola. A fixed point, this is a fixed point, and a fixed line. Okay. So you get this point. This is what I wanted to tell you. Now let us now what is the zero of a polynomial? Zero of a polynomial. Zero of a polynomial. Say your polynomial is px is equal to 3x plus 1. What numerical value is to be substituted for x so that this becomes 0? So that this becomes 0. What numerical value is to be substituted here so that this becomes 0? Then that value of x will be the 0 of this polynomial. Okay. So you have to make 3x plus 1 equal to 0. Therefore 3x plus 1 minus 1 here and minus 1 here also. 0 minus 1 is minus 1 and this to cancel. So 3x is equal to minus 1. Now you divide by 3 and divide here also by 3. You get the value of x. It is minus 1 upon 3. Okay. So let us check it. So 3 into minus 1 upon 3 plus 1. 3 cancels away. It is minus 1 plus 1 and that is equal to 0. The value of polynomial is 0 for x is equal to this. Therefore, x is equal to, therefore, minus 1 upon 3 is a 0 of polynomial 3x plus 1. Okay. Had this been 3x minus 1, then the 0 would have been plus 1 by 3. So 3x minus 1, we will, therefore 3x is equal to 1, therefore x is equal to 1. I am directly stating it. So x is equal to 1 by 3. So 1 by 3 is a 0 of polynomial 3x minus 1. Now, what is the geometric meaning of this? What is the geometric meaning of the 0 of a polynomial? What is the geometric meaning of the 0 of a polynomial? 0 of a polynomial. Geometric meaning of, of the 0 of a polynomial. And if it is linear, then only one 0. One 0 means the point through which this polynomial will pass. 0, geometric meaning of the 0 of a polynomial. Let the polynomial be 3x minus 1. Let us plot it. Let us plot it. X, 3x, and then 3x minus 1. When we plot 3x minus 1 straightway even. What is the value of P1? P1 means value of the polynomial when x is equal to 1. So P1 will be 3 into 1 minus 1, that is 3 minus 1, that is equal to 2. What is the value of polynomial? P2. P2 is the value of this polynomial when x is equal to 2. So 3, 2 minus 1, that is equal to 5, 6 minus 1, that is equal to 5. What is the value of p minus 1? That is the value of the polynomial when x is equal to minus 1. And so on. Minus 3, minus 1, minus 4. Nowhere it is 0. It is 0 when 3x is equal to 1 is equal to 0. 3x minus 1 is equal to 0. 3x is equal to 1, that is x is equal to 1 by 3. So p1 by 3 will be 0. P1 by 3 will be 0. Okay. Now let us plot P1. P1 is equal to 2. P1 is equal to 2 means when the value of x is 1, the value of Px is 2. So this is the point through which the polynomial graph of the polynomial will pass. This is for P1 we are plotting. P1 here 1. 1 x value 1. The value of Px is P1. P1 is equal to 2. What is P2? P2. It is 5. So this is 3. This is 4. This is 5. So this is the point. This is the point. With 2 points we can plot the graph. Straight line. It is a straight line because it is linear. Okay. So yeah, this will be the plot for the polynomial Px is equal to 3x plus 1. This Px, plot for Px, is a straight line because it is linear and it is passing through this point. And the value of x for this is x is equal to 1 upon 3. So this is the 0 of the polynomial. This is the 0 of the polynomial. The point through which this straight line crosses the axis of x. X is the variable. We are plotting x here. So this is the 0. If it is crossing at 2 points, then the 2 zeros of that polynomial. But A quadratic only can have two zeros. Cubic will have three zeros. Zero means the point when we plot the polynomial, okay? When we plot the polynomial, the point through which the graph passes through the axis of x is the zero of that polynomial. Let the zero of a polynomial be 1, 2, and 3. Let the zeros of a polynomial are polynomial be 1 and 3, 2 and 3. Okay, then we can write this px as px is equal to x minus 2 into x minus 3. You may put some numerical value here. You may put say 4 or pi, anything. That will also satisfy this. Okay, may or may not. You may put or you may not put. Even if you put here, then the zeros of this polynomial will be x equal to 2. When x equal to 2, it will be 0. Okay. When x equal to 3, this term will be 0. Therefore, polynomial will be 0. You may put any numerical value. Any numerical value. 3, 2, what, root 5, anything. Root 5, anything. Rational or irrational. Okay. I am not putting. Let us multiply it. It will be x square minus 5x plus 6. Okay. Now let us plot this. What is that? Px is equal to x square minus 5x plus 6. As 2 and 3 are the zeros of this polynomial, then the first of all, it is a quadratic. It is quadratic. Its graph will be parabolic. Number 1 point. Number 2, at the zeros are 2 and 3. Zeros are 2 and 3. Then the graph will pass through the points 2 and 3 on the axis of x. Here px is this is point 1, 2, 1, 2, 3, 4, and so on. Let us make it 1, 1, 2, and 3. Increasing scale. Add the zeros of the polynomial are 2 and 3 because this is equal to x minus 2 into x minus 3. So zeros are 2 and 3. Plus 2 and plus 3. These are the zeros. So the parabola will pass through these 2 points. And now the parabola may be like this, downwards, open upwards, or it may be open downwards. It has to pass through these 2 points. Okay. Now what is the what must be the shape, this way or this way? Okay. We will find the value of the polynomial for any point in between 2 and 3. Between 2 and 3, the point is 5 by 2. So we will find the value of p 5 by 2. If it is positive, then it will be like this. If it is negative, it will be like this. Okay. We are drawing rough graph only. P 5 by 2 is 5 by 2 square minus 5 into 5 by 2 plus 6. This is 25 by 4 minus 25 by 2 plus 6. Okay. LCM is 4. 25 minus 50 plus 24. 25 by 4, 25x plus 6. X is 5 by 2, 5 by 2, 5 square, 25 by 4, 25 by 2, 50 by 4 plus 24 by 4. This is 49 minus 50 by 4. So this is minus 1 by 4. So it will be like this. Open upwards. It will be open upwards. Here the value is minus 1 by 4. This is 1 minus 1 by 4. Okay. So we are drawing approximately what is the value of this. What is the graph of this? It must pass through 2 and 3. As it is of this type, quadratic, it is a parabola. It must be a parabola passing through 2 and 3. It either in this way or this way. Let us check what will be this way. Let us substitute 5 by 2 for x, and point between this and this, it is 5 by 2. We are finding that the value is minus 1 by 4. That is this way. Therefore, graph will be this. Okay. Now, when the graph will be upwards, just change this x square. Just change this. Write this polynomial as minus x square plus 5x minus 6. Okay. It will be in fact minus x square minus 5x plus 6. Okay, minus x minus 2, x plus minus 3. So zeros are 2 and 3, same way, something, same thing. Zeros are here. It is a parabola. It is a parabola. This is quadratic, therefore parabola. So parabola passing through this point, this way, open upwards or open downwards. Let us find. So same p 5 by 2. Let us find the value of p 5 by 2. It is minus 5 by 2 square plus 5 into 5 by 2 minus 6. This is minus 25 by 4 plus 25 by 2 yani 50 by 4 minus 24 by 4. This is minus 25 plus 50 minus 25 4 by 4. This is 1 by 4. 49 and 50. 1 by 4. So this is positive. So it is like this. It is positive. So it will pass through this. So like this. You must know what way the graph will be. What type the graph will be. It will pass through 2 and 3 because the zeros are 2 and 3. And whether this way or this way, up or down, downward, open downward or open upward, you can find, substitute any value of x in between these two zeros. This is 5 by 2. So find the value of polynomial at 5 by 2. It comes out to be 1 by 4. So it is upward. So it will be facing down. So whenever the coefficient of x square is negative, it will be facing downward. It will be. Okay. Now, some other example. Suppose your polynomial is Cx is x minus 2 into x minus 2. There are two zeros, but both the values are same. It is x square minus 4x plus 4. Okay. From this you get this thing. This is the question, and you factorize it, and you get x square minus x minus 2 into x minus 2. So the zeros are x is equal to 2. Both the zeros are same. 1 point, only 1 0 actually. Okay. Now let us plot the what will the shape of this, let us know without plotting point by point. Without plotting point by point. You can plot it point by point. X is equal to 0, then x is equal to 1, then x is equal to 2, then x is equal to 3, and like that, and you can plot. So the 0 is x is equal to 2. Both the zeros coincide. This is 1 say, this is 2. Both the zeros coincide. This is the zero of the of the of the polynomial, which is quadratic. Now this will be like either this way or this way. Which way will it be? Which way will it be? That will depend. Just find out its value at 1. At x is equal to 1. If it is negative, then it will be like this. If it is positive, then it will be like this. But only 1 point. P1. Let us find P1. P1 is equal to 1 square minus 4 into 1 plus 4. This is 1 minus 4 plus 4. But yeah, that is you get 1. That is from this. That passes through this point. P1 is equal to 1. 1, 1. Okay. So your graph will be like this. It will be parabola touching the axis of x, touching the axis of x. This is parabola touching the axis. It is not circle. It is a parabola touching the axis of x at point 2. It is at point 2, x is equal to 2, and it is open upward. Open upward. Okay. Now if had this px been like this, minus x square plus 4x minus 4. Had this been like this, then take out minus common. It will be x square minus 4x plus 4. That is equal to minus x minus 2 into x minus 2. Even without calculating the value of p1, you can say definitely with a definite view that it will be downward. Why? Because the coefficient of here x square is negative. Whenever the coefficient of x square is negative, it is only downward. It faces down, open downward, open downward. P1, let us confirm it. The value of P1 is equal to minus 1 minus 2 into 1 minus 2. Okay, so minus, this is minus 1 and this is minus 1, minus 1 plus 1 and minus here, so it is minus 1. So downward. That's what. Yeah, minus 1. Okay. Now so 0. Let us the same example, x square minus 4x plus 4. The previous question was this. We plotted this and it was oh, the 0 was 2, x equal to 2, 0 is 2, and therefore it is open upward parabolic op, upward open. Okay, because the coefficient of x square is first. Okay, now let us put substitute the next example, that px is something this like this 2, x square plus 4x plus 4 plus 2, that is x square minus 4x plus 6. Okay, what was this? That is plot. Okay, we are first plotting this and then we 2 plus 2. So this is 1, say this is 2. The coefficient of x square is positive. It will be open upward and it will be parabola because it's quadratic, and you know that you have plotted. It was like this. It was like this. Okay, it was like this. A parabola open upwards, open upwards, open upwards. Yeah. This is the plot for this x square minus 4x plus 2. X square minus 4x plus 2. What will be the plot for x square minus 4x plus 6? increase every point by 2 upwards, by 2. But that is the point. Every point by 2. Whatever that 2 value is, if it is 1 and it is 2, then increase this point by 2. This point will be here. Okay, this will shift to this point. This will shift to this point. This will shift to this point. This is going to infinity. This is going to infinity. Okay. Every point will shift upward plus 2, upward by 2, by 2. This point to this point, this point to this point, this point to this point, and so on. So your graph will be like this. Graph will be like this. Okay. This is parallel to every point will be just parallel. If you draw a line, small line, very small line here and here, those lines will be parallel. Okay, every point will shift upward by 2, by 2, by 2. You need not plot this whole. This you have plotted. This is this thing. So every point, as every point will go up by 2, up by 2. So it will again be parabola because it is quadratic, and it won't cut the axis of x. Therefore, there is no zeros. There is no zeros for this. This is the plot for x square minus 4x plus 6. Okay, if you have any polynomial, say 3x plus 1, this is the polynomial, and make it equal to 0, then that becomes an equation, and from that you can find the value of x, which will make this polynomial 0. So from this we get that x is equal to minus 1, x is equal to minus 1 by 3, x is equal to minus 1 by 3 will make this polynomial 0. Okay. Similarly here you make it equal to 0. This is the polynomial, make it equal to 0, find the value of x. And probably you must be remembering that if an equation is like this, x square plus bx plus c is equal to 0, if not I will tell you later on, then the value of x is minus b plus minus under root b square minus 4ac upon 2a, upon 2a. Okay. So let us simply find the value of b square minus 4ac. Okay, what is the value of b square minus 4ac for this? B square minus 4ac is equal to, this is b, b is minus 4, this is a, and this is c. B square is minus 4 square, b square minus 4, a is 1, and c is 6 plus 6. This is 16 minus 4 square minus 24. So this is minus 8. So while you will be finding the the mm, the roots of this equation, then you will have this problem. The root of minus 8 and root of any negative number is an imaginary number. It is not real, not real, not real. As this is not real, we are not finding any zero. It is not cutting. It will cut only if there are real roots. If there are real roots, then only it will cut. It is not cutting. It means the roots of this equation will be will be unreal, imaginary. Okay, confirm. So this is not cutting, and may simply because the roots are not here. Okay, now let us make it minus 2, minus 2. So it will be 2. So it will be 2. Let us plot it. A rough diagram. We are plotting only the rough diagram. This you know that it is okay. This is 1, this is 2. What is the plot for this? It is a parabola. We studied this point. We have done it previously, and the coefficient of x square is positive, so open upward, so it will be like this, like this. Okay, it is a parabola, open upward, open upward. Now what will be the graph for, what will be the graph for this hole? For this it is this. For this it is this. It is starting at point x equal to 2. That is the 0 of the polynomial. Okay, minus 2. It is minus 2. So decrease every point. So, okay, decrease every point by 2. By 2. By 2. Whatever is the value. This is 1. This is 1. This is 2. Decrease by 2. Decrease by 2. Say this. Okay. Decrease this by 2. Decrease this by 2. Decrease this point by 2. Decrease every point by 2. So you will get a graph like this. A graph like this. You will get a graph like this. At any point, if you do a tangent, and here at any point you do a tangent, these two tangents will be parallel. Small line. Tangent means the point where the line touches this, not crosses. It is just touches. That is the tangent. So these are parallel. These must be parallel. So you are decreasing every point. The value of polynomial decreased by every point. At every point you are decreasing it by 2. Value 2 decreasing. So it is, now you see that it is crossing. So it must have real roots. It must have real roots. And let us check whether this has real roots or not. X square minus 4x minus 2. This a is 1, this is b minus 4, and c is minus 2. Let us find the value of b square minus 4ac. If b square minus 4ac is positive, then we have real roots. B square is minus 4 square, minus 4 square minus 4, a is 1, and c is minus 2. This is 16 minus minus plus for 8, that is 24. That is positive quantity, and therefore it's, you can find its square root. It is a real number, real, okay, real, and therefore the result, there are zeros. ठीक है, एक होगा, one will be, one will be, one will be this, x is equal to minus b, b is minus 4, minus 4 plus minus root 24 upon 2 a 1 1 4 plus minus root 24 upon 2. You may take 4 common, root 6, that is 4 plus minus 2 root 6 upon 2, that is 2 plus root 6, and 2 minus root 6 are the roots of this. So here this value will be 2 minus root 6, or this is 2 plus root 6. Actually this will be this way. This will be from outside this origin. This 0 will be here somewhere. This is 2 minus root 6. Root 6 is greater than 2. So it will cross some negative value. Some negative value. This is 2 plus root 6. This is 2 minus root 6. It will be negative value. It will pass from any point in the negative x values. Okay, because you are breaking 2 down. Okay, now the thing is, you can plot the graph for any quadratic polynomial. Okay, thank you. Next time.